Hi everyone, welcome to Homeschooling SAT Prep channel. Today we are going to start part 2 of Scatterplot, in which we are going to take non-linear relationship problems. In non-linear relationship, we have two types of problem. Either it can be a exponential graph or a parabolic graph. So these are the things that we are going to study in part 2 of Scatterplot. First, we are going to start with the basics of exponential function and quadratic function. Then we will take some problems on it. And at the end, I'll give you some practice problems. In part 1, we have studied basics of scatterplot and linear function. We took then I took some around 11 previous year questions, and at the end I gave you some 5 practice questions which you can solve by yourself and write down your answer in the comment section below. So if you haven't watched part 1, I'll request you to go watch part 1 first, then come to this part 2, because I have covered few basics of scatterplot in part 1. If you're thinking seriously to prepare for SAT examination, you can check out our homeschooling app and website. All the courses are available at a very affordable price. All the links are provided in the description below. Now, let's move on to the basics of exponential function. Function whose exponent is a variable is called as a exponential function, and it is represented in form either fx is equal to a times b to the power x, or y is equal to a times b to the power x. Both of them are the same thing. When it is given in fx form, then it is called as an exponential function, and when it is given in y form, then it is called as an exponential equation. So as the definition say, exponential function is a function whose exponent is a variable. As we can see here, y is equal to a times b to the power x. So our exponent is a variable here. For those who don't know what is an exponent, so exponent is used to represent repeated multiplication of same number. Let's say 2 square. So it can be said that 2 is multiplying 2 times. So our exponent is 2 here. Similarly, 2 to the power 4. So 2 will be multiplied 4 times. So our exponent would be 4, because exponent is used to represent the repeated multiplication of the same number. So 2 is multiplying 4 times here. So our exponent is 4. Now, as we know, this is our basic exponential equation. So what are a and b? A is called as your y-intercept. So what is y-intercept? It is the value of y when x is equal to 0. Let me show you why a is called as a y-intercept. This is our basic exponential function, that is y is equal to a times b to the power x. So a is your y-intercept when value of x is equal to 0. So let's put x is equal to 0 here. So what is going to be y here? So a into b to the power 0. So anything to the power 0 would be 1. So we can say that y is equal to a times 1. So a is equal to y. So when x is equal to 0, a is equal to y. That's why a is called as your y-intercept. Now b is called as your factor, or what you multiply by. You will understand this when we will solve this, example here, why b is called as a factor or a multiplier. So as we can see, we have an exponential function. How are we going to find that this is an exponential function or not? As we can see, the exponent is a variable here. So this is an exponential function. Now we'll put x and y, x value as 0, 1, 2, 3, 4, and we will find the output y. So from this equation, y is equal to 5 times 2 to the power x. So when we put x is equal to 0, so y would be 5 into 2 to the power 0. So that would be 5. So when x is equal to 0, y is 5. Similarly, when you put x as 1, your output y would be 10. Similarly, when you put x is equal to 2 in this equation, your output would be y would be 20. When you put x is equal to 3, your y would be 40. When x is equal to 4, your output y is 80. As we can see here, whenever we are increasing x by 1 unit, y value is increasing 2 times into 2. As we can see, when x value is increasing from 0 to 1, y value is increasing from 5 to 10, that is twice of 5. Similarly, when x value is increasing from 1 to 2, y value is increasing from 10 to 20. So this is also 2 times. Similarly, this is also 2 times. Similarly, this is also 2 times. So because, as we can see, the y value is increasing 2 times, or we are multiplying the next value of y is 2 times the value of previous value of y. So that's why 2 is going to be your multiplier or a factor, because uh, every next value of y is twice of the previous y value. So that's why it is called as a multiplier. So b is called as a factor or a multiplier because y value next y value is 2 times the value. As you can see, 10 is 2 times the previous value of y, that is 5 here. So now you know what is y-intercept. A is your y-intercept. As we can see here, when x is equal to 0, then y is equal to 5. So you can also directly find from this. So y is equal to 5. So this one would be called as your, this input and output would be called as your y-intercept. And the y value is increasing 2 times. So that is, so 2 would be your multiplier. Now let's put this input output table data on the graph. So as we have, when x is equal to 0, y is equal to 5. When, similarly, when x is equal to 1, y is equal to 10. When x is equal to 2, y is equal to 20. When x is equal to 3, y is equal to 40. And when x is equal to 4, y is 80. And when we join all the coordinates, we will get a exponential curve. Exponential curve. So this graph is called as an exponential curve. So in the examination, either exponential function or equation would be given to you, and you have to find what kind of exponential curve it would be, or or either you have to find the reverse of it. An exponential curve would be given with few coordinates, and you have to find what is going to be the exponential function or the exponential equation. Let's say exponential curve is given, let's say, and with two coordinates are given, this coordinate and let's say this coordinate. So this coordinate was 1 when x is 1, y was 10, and this one was when x is 4, y was 480. So in the examination, you will get the Desmos calculator. You can directly put the graph on the calculator and you can find it. But for those who want to learn how we can find the exponential equation from this exponential curve with two coordinates provided, any two coordinates provided on the exponential curve, we can find its corresponding exponential equation. Let me show you how we're going to find it. So as we already know, fx is equal to a times b to the power x. And we are given with two coordinates where x is 1, then y is 10, and when x is 4, then y is 80. So now we're going to put it here in the equation. So a times b. So we'll put function f1 as we'll take value of x as 1. So b to the power 1 is equal to y, as we, this is our basic equation here. So a into b to the power x, x value is 1, then y is 10. So this is our equation number 1. Now let's see, now this is another coordinate where x is 4 and y is 80. So when x is 4, then a into b to the power x. So x is 4 here, and corresponding y value is given as 80. So now we have two equations here. So what we're going to do here is we'll divide equation 2 by equation number 1. So this one would be a into b to the power 4 divided by a into b to the power 1 is equal to 80 by 10. A get cancelled and it would be 3 times. So b cube is 8. So b would be 2. So we already know the value of b, that is your factor or the multiplier, that is 2. Now how are we going to find the value of a, that is our y-intercept? So we'll take any of these two equations. Let's take equation number 1. So what we're going to do here is we're going to put the value of b in equation number 1. So the equation number 1 is a into b to the power 1 is equal to 10. So a into b to the power 1 is equal to 10. So a b to the power 1. So 2 times 1 is equal to 10. So what you're going to do, we're going to divide both the sides by 2. So a 2 by 2 divided by 2, 10 by 2. So a is your a is equal to 5. So now we know the value of a and b. So we can find our function here. So our function fx is equal to a, that is 5, multiplied by 5 times 2, b is a 2 to the power x. So this is our function here. So you will get either to find the exponential curve from the exponential equation, or our exponential curve would be given to you with at least 2 coordinates, and you have to find its corresponding exponential function or equation. We have 2 types of exponential curve. As we can see here, when the curve is rising like this, then we call it as an exponential growth curve. And when we can see the graph is falling like this, then we call it as a exponential decay curve. Now let's take 2 examples here. This is our example number 1, and this is our example number 2. So as we can see in example number 1, our equation is y is 3 times 2 to the power x. So what is going to be our y-intercept and our factor? So as we already know, y is a times b to the power x, where a is our y-intercept. It is the value of y when x is 0, and b is called as a factor. So when we put the basic exponential a times b to the power x, so from this we can say that our factor b is 2 here, and our y-intercept a is 3 here. Now let's put this ex this exponential equation on the graph. This is our input-output table. As we can see here, when x value is increasing by 1 unit, y value is 2 times. It's 2 times. The next y value is 2 times of the previous y value. So from this we can say that our multiplier or our factor is 2 here. And when we put x value is 0 in this equation, then we will get y value as 3. So 3 is going to be our y-intercept. And as we can see here, we can put, when we put this input-output table on the graph, we'll get an exponential growth graph here. And as we can see here, when x value is increasing, y value is also increasing. And it is increasing 2 times, and that 2 would be called as a factor or a multiplier. Now let's take another example here. The equation is y is equal to 144 times half to the power x here. So what is going to be our y-intercept? So y is a times b to the power x. So a is 144, and factor b is half. So now let's put x and y value in an input-output table. When we take x value as 0, 1, 2, 3, 4, as we can see here, the value is increasing by 1. But here, as we can see here, the value is multiplied by half. Because 144 into half would be 72. Similarly, the next value of y is half times of the previous value. Similarly, 18 is half times of previous value. Similarly, 9 is half times of previous value, that is 18. So what is going to be our multiplier here? Because the next y value is half of the previous high value, so our multiplier or the factor b is half here. So now when we put this equation here, we can see our graph is falling like this. So this is an exponential decay graph. So here, as we can see, when x is increasing, as we can see, x value is increasing from 0 to 1, 2, 3, 4. We can see y value is decreasing with a multiplier of half. When x value increases, y value also increases. That means it is an exponential growth curve. But when x value increases, but y value decreases, then it is an exponential decay curve. You can find that a graph is an exponential growth or exponential decay graph just by knowing the value of factor b. Factor b is greater than 1. Anything greater than that is 1.1, 1.05, 2, 20, 80, any number that is greater than 1. If the factor is greater than 1, then we will have a exponential growth graph here. As we can see here our factor b is 2, that is greater than 1, then we are getting a exponential growth graph here. But when the factor is between 0 and 1, always remember it should not be equal to 0 and it should not be equal to 1. It should be between 0 and 1. So when the factor value is between 0 and 1, as we can see here in this equation, the factor value is half, that is 0.5, that is between 0 and 1, then we will get an exponential decay graph. So this is very important. If you can just go through the equation and you can find that the curve is an exponential growth curve or an exponential decay curve. Now, these are 4 more examples, and you have to tell that in these 4 exponential function and equation, we will have an exponential growth or an exponential decay graph. So please pause the video here and come back when you are ready to compare your answer. I hope you have tried all these 4 questions. Now let's solve these questions together. So in example number 1, fx is 3 times 5 to the power x. As we can see, the exponent is a variable, so it will have an exponential graph. Now let's find out it's going to have an exponential growth graph or an exponential decay graph. So as we can see, as we know, fx or y is equal to 8 times b to the power x. So as we can see here, b value is greater than 1. So when b value is greater than 1, we have a exponential growth graph here. When b value is greater than 1, and when b is between 0 and 1, we will have an exponential decay graph. So here, in example number 1, we have b value that was greater than 1, factor value was greater than 1, so we will have an exponential growth graph. Now in example number 2, y is 6 times 1/3 to the power x. So 1/3 can be also written as 0.33. So b value is between 0 and 1. So for when factor b value is between 0 and 1, we will have an exponential decay graph. So we will have an exponential decay graph. In third example, the b value is between 0 and 1. So again, we will have an exponential decay graph. In fourth example, the b value is greater than 1. So we will have an exponential growth curve. Now, one more thing that you need to remember, that b can never be negative, can never be 0, can never be 1. See, it can never be negative, and when it is between 0 and 1, then it is a exponential decay graph. And when it is greater than 1, then it has an exponential growth graph. So you need to remember, and b value can never be negative, 0 or 1. You need to remember this. This is very important. Now, let's move on to the questions now. The question number 1, it says that the scatter plot shows the relationship between 2 variables, x and y. An equation for the exponential model shown can be written as y is equal to 8 times b to the power x, where a and b are positive constant. So which of the following is closest to the value of b? So we have to find the value of b, and this graph is given. So as we can see, this is an exponential decay graph. So we have just read about exponential growth and exponential decay. For exponential growth, the factor value b should be greater than 1, and for exponential decay, b value should be between 0 and 1. So as we can see, this is an exponential decay graph. As you can see, the graph is falling, so it is an exponential decay graph, and our b value should be between 0 and 1. So let's check the options here. So as we can see, 0.83, the value is between 0 and 1. So hence option A is the correct answer. So the value of b is 0.83. Now, in question number 2, it says that the scatter plot below shows the world population P in billions, where X is the number of years since 1950. Which of the following is the best exponential model for this data? So as we can see, this is an exponential growth graph, because in the question we have to find the best exponential model. So this must be an exponential growth graph. So this is an exponential growth curve, and this is our basic exponential equation, that a into b to the power x, where a is our y-intercept, which is the value of y, value of y at x equal to 0. Now, in the graph, as we can see here, this plot, this coordinate, when x is 0, y is around 2.5. So we can find our y-intercept from here. So our y-intercept a is is approximately around 2.5. So our a is around 2.5. Let's see the option here. So we are getting two options where a value, that is the y-intercept value, is 2.519, 2.519. So we'll consider these two options, and we'll discard other two options. Now, as we can see, this is an exponential growth graph. So our factor b would be greater than 1. So among these two options, as we can see here, b is less than 1 and more than 0, and here b is greater than 1. So as we know, for exponential growth graph, the value of factor b should be always greater than 1. So here the b value is greater than 1. So option A is your correct answer. Now we're going to start the basics of quadratic function. So what is a quadratic function? Quadratic function is a polynomial function in which one or more variable, in which highest exponent of the variable is 2. And the standard form of quadratic function is given as either fx is equal to ax square plus bx plus c, or y is equal to ax square plus bx plus c. So when fx is equal to x square plus bx plus c is given, then it is an quadratic function. When y is equal to ax square plus bx plus c is given, then it is a quadratic equation. And as we can see, this is our standard form of quadratic function. And as we can see, it is a polynomial function with one or more variable. So as we can see, we have two variables here, x and y here, with highest exponent of the variable is 2. So as we can see, we have two variables, x and y, and the highest exponent of the variable here in the x is 2. So any equation which have one or more variable with highest exponent of the variable is 2, as we can see here, then that function will be called as a quadratic function. And here a, b, c are real number, and a can never be equal to 0. And one more thing, a quadratic equation will give a parabolic curve. And the parabolic curve can be of two types. In first type, the parabolic will have an opening in upward direction, and a parabolic curve will have an opening in downward direction. Now let's take an example of quadratic function. Let's say this is a quadratic function, fx is equal to 2x square plus 4x negative minus 5. So when we will compare these two equations, when we compare with the standard form, we can find the value of a. As we can see here, ax square. So a would be 2 here, bx. So b would be 4 here, and we can also write it as plus and negative 5. So plus c. So c would be a negative 5. Similarly, in this example, where fx is equal to x square minus 2x minus 3, a, as we can see, x square, if you multiply x square with 1, it will still remain x square. So here a would be 1. Then we will take b, we'll put plus sign, and we'll take negative 2 inside. So b will be negative 2. And similarly, c will be a negative 3. Now, there is one more form of quadratic function that is called the vertex form, where fx or y is equal to a into x minus h whole square plus k. We will cover this vertex form while we will solve some questions. Now, there are some basic terms in a quadratic function. The first one is vertex. So what is the vertex? Vertex is a point where function has maximum or a minimum value. So as we can see, this is a parabolic curve. This is a quadratic function, and when we put it on a graph, we will get a parabola with an opening on the upward direction or in a downward direction. When the parabola is having an opening in upward direction, then the vertex will be the minimum value here. That would when the parabola is opening in upward direction, and when the parabola is opening in downward direction, then the vertex is your maximum value. Now, as you can see, we have a quadratic equation here. Y is equal to x square minus 2x minus 3. And as we know from the definition, it should have one or more variables. So we have two variables, x and y, in which highest exponent of the variable is 2. So as we can see, x exponent is highest exponent of variable x is 2. So this will satisfy as a quadratic equation. And when we make the graph of it, it is having a parabolic curve with an opening in upward direction. So when we have an opening in upward direction, then what is going to be the vertex? Vertex is going to be the minimum value. So here our minimum value is, this is our vertex here, and its value is x. When x is 1, y is negative 4. So for this question, our vertex is 1 and negative 4. The vertex coordinate is 1 and negative 4. Now, what is axis of symmetry? So axis of symmetry is a vertical line which intersect the parabolic function at the vertex and divide it into two equal parts so that they can overlap on each other. So it's a vertical line. It's a vertical line. It's a vertical line that intersect the vertex. So this is our vertex here. And as we can see, when it intersects the vertex, it divides it into two equal parts. So whatever is there on the left side, we can see it is also on the right side. So when we fold, if you draw this on a piece of paper, and when we fold it along the axis of symmetry, this is our axis of symmetry. Axis of symmetry. If we draw it on a paper and if we fold it along the axis of symmetry, this will overlap on this when we will fold it from the between on axis of symmetry. Now, and as you can see, this axis of symmetry is dividing this parabolic curve in two equal parts. So this side is similar to the other side. Now, what is going to be our axis of symmetry? As we can see here, axis of symmetry is a vertical line. So it is at x is equal to 1. So axis of symmetry is 1, because that vertical line is passing through x is equal to 1. And our vertex is given here as 1, negative 4. Now, what is a y-intercept? Y-intercept is the value of y at x equal to 0. On this graph, as we can see here, this is our y-intercept. This is our y-intercept. Here, x is 0. When x is 0, y is negative 3. So this is our y-intercept. So what is our y-intercept? So y-intercept is negative 3. Now, what is x-intercept? X-intercept is value of x at y equal to 0. As we know, on this line, y is equal to 0. And so our x-intercept would be these 2 points. So these 2 points would be our x-intercept. It is the value of x. So this is 3, 0, and this is negative 1, 0. So x-intercept is the value of x at y equal to 0. So when x value is negative 1 and positive 3, then y is equal to 0. So our y-intercept would be negative 1 and 3. Now, what is a domain? So domain is a set of x values for which function is defined, So what I'm trying to say, as we can see, x value is x value on this point, x value is negative 2. On this point, x value is negative 1. On this point, x value is 0. On this point, it's positive 1. On this point, it's positive 2, on this point x value is positive 3, and on this point x value is positive 4. And as we move, as this parabolic graph, it will move further away. So it will be from, x value will be from negative infinity 0 to positive infinity. We will have all the real numbers from negative infinity to positive infinity. So hence we can say that domain is, hence domain for this graph would be from negative infinity to positive infinity, or we can also write it as x value has all real numbers. We'll have all real numbers. So for domain, we will find the set of x value for which function is defined. For range, we will find set of y values for which function is defined. For domain, we will have to find the set of x values, and for the range, we have to find the set of y values for which function is defined. So as we can see here, the lowest y value is -4, and highest it can go up to infinity. So your range y would be greater than or equal to -4, or it can be also written as y is greater than -4 and less than infinity. So it is from -4 to infinity. Now, what is the maximum and minimum value? So value of a function, it always refer to the y value. So the maximum and minimum value in a quadratic function is your y value. So your maximum is, as we have found that in this graph, the maximum is, it is going till infinity. So maximum is infinity, and minimum value is -4 here. So minimum value is -4. Now there's one more thing that I forgot to tell you. As we can see, when we have a quadratic function, we will have a parabolic curve with an opening in upward direction, or a parabolic curve with an opening in downward direction. So if we have to identify that a quadratic equation is given, then what kind of opening it will have? Will it have an opening in upward direction or a downward direction? So as we know, our basic quadratic equation is y is equal to a x square plus bx plus c. So if a value is greater than 0, so if a value is greater than 0 or positive, then the parabolic graph curve will have an opening in upward direction. So if, let's say, if we have an equation where ax square, so let's take any positive number greater than 1, ax square plus 3x plus 9. So as we can see here, a value is greater than 0, or it's a positive value. So whenever the a value is greater than 0 or any positive number, then then your parabolic curve will have an opening in upward direction. And when the value of a is less than 0 or a is negative here, then the parabolic curve will have a opening in downward direction. So if we have an example like minus 3x square minus 6x plus 9. So here, as we can see, a is -3, so a is less than 0. So whenever the a is less than 0, then we will have a parabolic curve with an opening in downward direction. Now, I've taught you earlier that there is one more form of quadratic equation that is called as vertex form, where fx or y is equal to a into x minus h whole square plus k, where a is called as leading coefficient. Leading coefficient. Now, what is the use of this vertex form? Let's say a parabolic curve is given to you, and let's say 2 points are given. Let's say vertex is given to you, that is 1 and -4, and any other point on this parabolic curve. Let's take this point as given. This point is also given. This is 3 and 0. So a question is given in which a parabolic curve is given and vertex and other coordinate on the parabolic curve is given. So how we are going to find the quadratic equation from this curve here? So y is equal to a in a times x minus h whole square plus k. So it can be also written as y minus k is equal to a into x minus h whole square. It is the vertex form, so we'll use the coordinate of vertex, that is x and y. So here x is equal to 1. So x is equal to 1. It can be also written as, if we'll take 1 on that side, so it will be x minus 1 is equal to 0. Similarly, y is equal to negative 4. So it can be also written as y plus 4 is equal to 0. So we will replace we will replace the k and h value with these two. So we'll write a is our leading coefficient, and here we will write x minus 1 square. So whatever it is given in the vertex, we will just take the opposite sign and we will equate it to 0. So x was equal to 1, so x minus 1 is equal to 0. So we'll take this x is 1 whole square, and y is y plus 4. So y plus 4. Now from this we can say that a is equal to x, sorry, a is equal to y plus 4 divided by x minus 1 whole square. So now in the question, in the graph, it was given the two coordinates were given. One was the vertex, this one was the vertex, and one more point was given, one more coordinate it was given, that was 3 0. So what we're going to do here is we're going to put this x and y value of other coordinate in this equation to find the value of leading coefficient a. So here y is 0 and x is 3. So 0 plus 4, that would be 4, and x is 3, so 3 minus 1, 2, 2 whole square, so that is 4. So the value of a is, leading coefficient is 1. So now what we're going to do here is we are going to equate them. So now we will put this value of a in equation number 1. So y plus 4 is equal 1, a is 1, x minus 1 whole square is x square plus, sorry, x square minus 2x plus 1. So y is equal to x square minus 2x, and we'll take plus 4 on that side. So 1 minus 4, that would be negative 3. So as we can see here, we have got our quadratic equation here. That is y is equal to x square minus 2x minus 3. So the vertex form is used when the graph is given to you and you have to find the quadratic function. Then you're going to use the vertex form. Now let's move on to the questions now. Now, in this question, it is asked, among the following, which is the best model for the data in the scatter plot? As we can see here, we have a parabolic curve here. So we will going to have a quadratic equation, and the parabolic curve is opening in upward direction. That means the value of a should be greater than 0. As we can see here, as we know, the basic quadratic equation is y is equal to ax square plus bx plus c. And when we have a parabolic equation, parabolic curve with opening in upward direction, then we should have a greater than 0. So as we can see here in option C and D, a is negative. So we are going to discard option C and option D. Now, now what we're going to do next is we're going to find the vertex here. So vertex is when the vertex is what? Vertex when the parabolic curve is opening in the upward direction, vertex is going to be the minimum lowest value. So let's take this one as the vertex. That's because it's the lowest point, and on x-axis it is somewhere around 2.5, and on y-axis it is somewhere around 5. So the vertex coordinate is 2.5 and 5. One more thing that is known to us, that is our y-intercept, that is 0 and 20. When x value is 0, y is 20. So we know two things here, vertex and y-intercept. Now what we're going to do here is, in vertex, x value is 2.5, then the y value is 5. So what we're going to do here is, we're going to put x value for both the equation for in option A and B. And let's see that after putting x value as 2.5, we will get y value as 5 or not. So let's say in option A, y is equal to 2x squared. So here x is 2.5. So 2.5 whole square minus 11x. So x is 2.5 minus 20. So let me put it on my calculator. It will be around negative, approximately around negative 15. So option A is also incorrect, because when we put x value as 2.5, we should get y value as 5. But here y value is coming as negative 15. So option A is also incorrect. So ultimately option B would be your correct. Let's check it. Y is equal to 2 into x square. So 2.5 square minus 11 into x, that is 2.5 plus 20. So this one would be 5. So when we put x value as 2.5, we will get y as positive 5. Hence option B is your correct answer. Now let's move on to the next question. In this question, this is the last question. So Nikhil calculated his motorcycle's average fuel economy in miles per gallon for various speeds in miles per hour. On the scatter plot, not above, it should be below, he recorded his data along with a best fit curve to model the data. So we have to find these four things. So first, Nikhil's motorcycle achieved its approximate maximum fuel economy at a speed of what? So our maximum speed and fuel economy will be at the vertex. So vertex, as we can see, this is a parabolic curve, and it is opening in downward direction. So the vertex would be at the top. So it would be somewhere here. So what is going to be our vertex? Vertex would be around 47, 48. So speed would be 48, and corresponding fuel economy is around 68. So 60. So in question number 1, we have to find Nichols motorcycle achieve its approximate maximum fuel economy. So maximum fuel economy is at 68. Maximum fuel economy at a speed of at what? So maximum fuel economy is achieved at 68 miles per gallon, and its corresponding speed is 48 miles. So 48 miles per hour is our answer for question number 1. In part 2 of this question, Nikhil's motorcycle achieved maximum fuel economy of, so maximum fuel economy that is achieved is at 68 miles per gallon. So 68 miles per gallon. Now, Nikhil's motorcycle fuel economy increases by approximately dash miles per gallon as it accelerates from 0 to 50 miles. So it has started from here 0. So here, when speed was 0, fuel economy was 10 miles per gallon. And when it achieved 50 miles, so it would be here. So that would be 50, and fuel economy is 68. So what is the increase? Increase would be the difference of the fuel economy at 0 miles per hour and at 50 miles per hour. So at 50 miles per hour, the fuel economy is 68. So 68 minus, and fuel economy at 0 miles per hour is 10 miles per gallon. So 68 minus 10. So that is going to be 58 miles per gallon. So answer would be 58 miles per gallon. Now, in fourth part of the question, according to the Nikhil's graph, which of the following function best expresses Nikhil motorcycle's fuel economy E in miles per gallon as a function of his motorcycle's speed S in miles per hour. So for this parabolic curve, which is facing in downward direction, we have to find its quadratic equation. So as we know, whenever the parabolic curve is facing downward, a value should be less than 0 or should be negative. So here a value is positive and here a value is positive. So option C and D is incorrect. Now we have to choose from either option A or option D. So we already know the vertex. So vertex was 48 and 68. So 48 is our speed. This is our speed. And 68 is our fuel economy. That is E. And this is speed S. Now what we're going to do here is we will put the value of S in this both the equation, and we have to find in which of these two equation we are getting fuel economy E as 68. So now in option A is negative 0.025 s square. So s speed is 48. So 48 square plus 2.4, s is 48, speed is 48 plus 10. So es is equal to, now let me put it on my calculator. So negative 48. So it is going to be around 67.6. So that is almost equal to 68. Hence, option A is your correct answer, because when we put the speed S as 48, we get fuel economy ES as 68. So option A is your correct answer. Now let's find option B is correct or not. So what for option B? ES is equal to negative 0.25. S square is 48 square minus 2.4 into 48 plus 10. So we will get somewhere around 183. So option B is incorrect. For fourth part, option A is the correct answer. Now this is the end of this Scatterplot chapter. If you have bought the paid course, you will get one more video where I'm going to teach you 3 things for this Scatterplot chapter. First, I'll give you a few more tips and tricks to solve Scatterplot problem under a minute. Then how to use Desmos calculator effectively for this chapter. Then I will update you with new types of scatterplot problems asked in recent digital SAT examination, along with a full mock test for this chapter. And if you haven't bought the course, there's no need to worry. Now, these are a few practice questions on the topic which I have taught you recently in this video. Do solve these questions to test yourself and write down the answer in the comment section. Students who will answer all the questions correctly, their answers will get pinned in the comment section. If you like the way I teach and want to buy a comprehensive course for SAT exam starting at a very affordable price, you can check out our homeschooling app and website. All the links are provided in the description. One more thing, don't forget to like, share, and subscribe to this channel so you can get updates of upcoming free videos that I'm going to upload on YouTube in future. Thank you very much, and may God bless you.